Clicking this button triggers two HTTP requests. The first is a post to update the data, and the second is a get to retrieve the updated value. From the code perspective, it is as simple as calling this function, and when it completes, I can invalidate the router, and this other function is finally triggered. The real magic is that this is client code, basically a React component. But if I go into the functions and I open the terminal, you're gonna find that these two console logs are not in the browser, but they're here on the server. This is chapter 2 of the TanStack Start tutorial. Subscribe to the channel and let's begin. In the first episode, we followed the official documentation to create a server function reading a value from our server and an update function increasing the value by a set number. But are we really sure that we're gonna get a number from here? And that's why there's a validator API. This is the most simple validation, if we can call that validation anyway, as we're just using the identity function to make sure that this value is in fact a number. The effect here is that we get that data is now typed as a number, and also on our client code, we know that data is only gonna accept a number. But nothing stops us from saying here, hello, gets an error as number, and with that I'm now in fact passing a string, and this is probably gonna break. That's why at least you should make sure that this is really the type you're expecting, for example by throwing an exception in case this is not a number. And in this case you're fairly sure that this time t is gonna be a number. But since you can pass literally anything here, you might not want to write the validation logic manually every single time, and that's why you better use a validation library. For example, Zod can be one. In this case, if you have a schema defining your input, you can simply get rid of the entire validation function and just use the schema here. If we go back to our function that is in fact sending a string instead of a number, and we have the Zod schema defined here, when we go on the browser and try to call our function, well, this is gonna throw an error, and you can see from the response that it returned an error from Zod, specifically letting us know that it was expecting a number, but it received a string. The good news is that if you want to use any other schema library, for example, Valuable that follows the standard schema specification, just replace Zod schema with Valuable schema, and this works exactly the same way. But let's try to go to the next level. This time, let's say we're gonna accept a string. So here we use vo.string, and we can go back here, fixing our code. Now, hello is gonna be an accepted value, but that's just for the example. Here, I'm gonna send the string 2, and here in the function, this isn't complaining because you can obviously concatenate a string, but we want this to be a number. What can we do? With all the schema libraries, you can always add an extra step. For example, here I can pipe with Valibot and say that I'm gonna accept a string, but I'm gonna transform my string and I want a number instead. As a result, you're gonna see that our function here inside data accepts a string, then passes through the validation step, and when it goes to the handler, this time we're gonna get a number. And if we give it a try on the browser, this time it's gonna work. Even though in the payload we sent the string 2, thanks to our transformation during the validator step, this was correctly handled as a number. But the input can literally be anything, not just primitives like strings or numbers. You can also pass an object, and as long as the content is serializable, this is just gonna work. Now we see an error because this time data is an object with an increment field, so I can type data.increment, which I'm gonna expect to be a number, and I can also fix this one. And you can notice that as I change the schema here, I didn't even need to define any explicit type. The handler already knows that the input is an object with an increment field that is a number, and if I go back on the client code, data is again the right type. So I can define it, say that increment is 2, and again, if I go on the browser, this works just fine. This time it sent an object with increment 2, and the server function correctly validated and used that value. Speaking of serializable object, technically, you could also submit directly form data from your form, and after writing your validation logic, you can use your data here in the handler. And if you do that properly, you can also submit a form without JavaScript in the browser. And now that you know how to validate the input, you might want to subscribe to the channel because the next topic will be the output. We'll see together how to return not only primitives or serializable objects, but also redirects and not found errors, since they have a slightly different handling. With that said, thanks for watching this video and see you in the next one. Bye!